There aren't too many videos on YouTube about analyzing thunderstorms using pictures on the East Coast. This is a tornadic supercell in northwest Pennsylvania, April 20th, so springtime. You can see nice outline here in the cloud. There's a downdraft. It's sharing that and making it smooth. A lot of times that's an indicative of a tornado nearby. If it was upward moving air, it would probably most likely like 95% of the time be a tornado. You can see the clear slot caused by the rear flank downdraft, and that's what's making this very sharp, well-defined edge. Here's the rotating mesocyclone, and we will try not to take too long here. It's northwest Pennsylvania again, same storm, like 5 to 10 minutes earlier. You can see a big striation right here, indicative of rotating mesocyclones. There's the striations, they're kind of hard to see. A very large wall cloud, and there's some inflow coming into the storm. See here. This was in February of 2016, Oxford, North Carolina. You can see rain, and that rain is wrapping around the tornado. There's a tail cloud fitting into the meso and the tornado. The clear slot is not really that well defined, but there's no rain there. This is the area that I'm saying this is the tornado. It could be just some clouds also with it. There's a very sharp edge right here with rising air. So this most likely is the edge of the tornado. Where the other side is not very well defined. And here's some more. This could be a secondary wall cloud. Okay. We're going back again to the April 20th storm in northwest Pennsylvania. This was earlier when the storm was a little bit stronger. Well, that's hard to tell with the shot. You see, you can try to delineate the gust front by a shelf cloud here, a level cloud. Here's where the meso is rotating, mesocyclone. Here's the downdraft area where it's a little bit clearer. Let's take a look at back. Alright, this is without the graphics, without the writing on it. You can hopefully see that gust front delineated by a shelf cloud a little bit easier here. Just the meso and clear slot. So that's all I have for the April 20th, 2017 tornado. And there's 4 other events here. Here's also another North Carolina event. I don't know if there's such thing as a primary wall cloud, secondary, but this primary is closer to the thunderstorms center where the rain and hail is. And here's the tornado. You can see a collar cloud right here wrapping around it. The clear slot is right here. Clear slot associated with this tornado. This is in New York State, Mount Vision. The mesocyclone is right here. There's a little wall cloud nub inflow into the updraft. On video you could clearly see it, and the funnel is actually right behind it. And I knew something was up because the air was rising rapidly. Now that wasn't actually the funnel was behind it, but it was indicating something was going on. Tail clouds, they're actually right below the wording. I don't know if you can see it. You can see it a little bit better now. Right there, there's a few tail clouds coming in. This is also New York. It's more towards, it's not that far from Albany. Clear slot goes, looks like it goes from here all the way across. The wall cloud is generally in this area. The tail cloud is very long. Looks like it extends for a few miles. And if there was going to be a tornado, it would be on the north end, this wall cloud, and which I think is very typical. And you can see the clouds were actually rising up into that part of the wall cloud fairly rapidly. Storm in Scranton, PA. The skies are a lot greener than it shows on this video camera. It's a multicellular line with an embedded supercell. The other videos were not lines per se. One in North Carolina, the Oxford, one tornado wrapped in rain. That one might have been quasi-linear. Here you have some developing shelf clouds. Yeah, shelf cloud here. So there's cold air rushing into the warm air, lifting it, and that's really choked off this rotating wall cloud. But before it could do that, it did increase the rate of spin, I think. So you had the warm air coming in and cold air racing towards it. That's why I think tightened up that circulation. You don't see too many good thunderstorms in the east. There's some overshooting tops. Pretty large area of overshoot here. This was, I think, a severe thunderstorm. I think there were watches, warnings out. There's the anvil, and it busted through the anvil. There's even knuckles here. I'd rather call them like ribs or whatever. You can have a lot more than 5, and they're longer than knuckles. They're extending pretty far. The back shearing. This is the back side of the storm. In weaker storms, there is no anvil really that you can see on the back side. Most of the anvil is always on the other side over, well behind this thunderstorm. One more picture to, and you can see an anvil here, and then another anvil right here. with some like womatiform clouds maybe. But this is really overshooting quite a bit. There isn't a ton of back shear, just a little bit here maybe. And we also have a Peleus is this mountain of clouds present a barrier and provides like orographic lifting for air flowing above it. So it acts basically as a mountain. This is somewhat typical shape of lenticular clouds caused by orographic lifting. And that is it.